Stop using /24 subnets for everything in your VPC. I just reviewed an architecture where a company ran out of IP addresses in their database tier and had to rebuild their entire network from scratch, costing them 3 weeks of engineering time and a weekend outage.
Hey everyone, welcome back to the Network Ninja Cloudcast. I'm so glad you're here because I've definitely been guilty of just throwing /24s everywhere without thinking about it.
And that's exactly what we're going to fix today. By the end of this episode, you'll know exactly how to calculate the right subnet size for each tier of your application, and you'll never waste IP addresses or run out of them again.
Okay, so let me ask the obvious question. Why does subnet size even matter? Can't I just make everything big enough and call it a day?
Here's the problem. In AWS, your VPC has a maximum size of /16, which gives you 65,536 IP addresses total. That sounds like a lot until you realize AWS reserves 5 IP addresses in every single subnet, the first 4 and the last one. So if you create a /28 subnet, you only get 11 usable addresses, not 16. Now multiply that across multiple availability zones, multiple tiers, and suddenly you're burning through addresses fast.
Wait, so if I create a bunch of /24 subnets thinking I'm being generous, I'm actually wasting huge chunks of my VPC's address space?
Exactly. A /24 gives you 251 usable addresses after AWS reservations. If your web tier only needs 20 instances max, you've just wasted 231 addresses. Do that across 3 availability zones and 2 environments, and you've burned through over 1,500 addresses for no reason.
Okay, that makes sense. So how do I figure out the right size?
Think of it like booking hotel rooms for a conference. You need to estimate your maximum attendance, add a buffer for growth, and then book the right number of rooms. You wouldn't reserve an entire floor for a team of 10 people, but you also wouldn't book exactly 10 rooms with no buffer. The formula I use is this. Take your maximum expected instances, multiply by 1.5 for growth buffer, add 5 for AWS reserved addresses, then round up to the next power of 2.
Can you walk me through a real example? Let's say I'm building a 3-tier app with web servers, application servers, and databases.
Perfect. Let's say your web tier needs up to 50 instances for autoscaling during peak traffic. 50 times 1.5 gives us 75, plus 5 reserved equals 80. The next power of 2 is 128, which is a /25 subnet. For your application tier, maybe you need 30 instances max. 30 times 1.5 is 45, plus 5 is 50. Next power of 2 is 64, so that's a /26. Your database tier with RDS might only need 10 addresses for primary, standby, and read replicas. 10 times 1.5 is 15, plus 5 is 20. Round up to 32, giving you a /27.
So instead of 3/24 subnets using 768 addresses, I'm using a /25, a /26, and a /27, which totals only 224 addresses?
Now multiply that by 3 availability zones for high availability. With /24s everywhere, you'd use 2,304 addresses. With right-size subnets, you're using 672. That's a savings of over 1,600 addresses that you can use for future services, additional environments, or VPC peering ranges.
This is clicking now. But what about private versus public subnets? Does that change anything?
Great question. Public subnets with NAT gateways or load balancers typically need fewer addresses because you're not running application instances there. I usually go with /28 subnets for public tiers, giving me 11 usable addresses per availability zone. That's plenty for a NAT gateway, a bastion host, and an application load balancer. Your private subnets where the actual compute lives get the larger allocations we calculated.
What's the biggest mistake you see people make with this?
2 things. First, not planning for multi-aws from the start. If you use a /24 for your web tier in one aws, you can't easily split it later when you need high availability. Always design for at least 3 availability zones from day 1. Second, forgetting about AWS services that consume IP addresses. Lambda functions in a VPC, ECS tasks with aws-VPA networking, and EKS pods all need IP addresses. I've seen people run out of addresses because they sized for EC2 instances but forgot their containerized workloads.
So let me make sure I've got this. Step 1. Calculate max instances times 1.5 plus 5 reserved, then round to the next power of 2. Step 2. Plan for 3 availability zones from the start. Step 3. Account for all IP-consuming services, not just EC2.
Perfect summary. And here's my pro tip. Document your CIDR allocation in a spreadsheet before you create anything. Map out your entire VPC with all subnets, their purposes, and their sizes. It takes 30 minutes up front but saves you from that painful rebuild I mentioned at the start.
This is so much clearer than just guessing. I'm definitely going to audit my current VPC setup after this.
That's it for today's episode. If you found this helpful, please hit that like button and subscribe to the channel.
And share this with anyone who's building out their AWS infrastructure. This stuff matters.
Thanks for watching the Network Ninja Cloudcast. See you in the next one.